I'm Andrea Zonca. I work at the San Diego Supercomputer Center, and I will be presenting today about a tutorial on how to use distributed computing with Dask on the cloud resource Jetstream2. So in this tutorial, I will be showing you two different aspects. On one side, I want to show you how, from the user perspective, you can use distributed computing with Dask to do computations on multiple nodes on Jetstream. And on the other hand, I want to show you how I want to show you the architecture of this deployment so that you might see if this is a good fit for a science gateway you're working on. And I will also be sharing links to all the more in-depth tutorials on how to deploy all the different pieces of this infrastructure on Jetstream so that you can test or deploying a system like this on your own Jetstream2 allocation. Okay, so first of all, the first step of the deployment is we have multiple virtual machines on OpenStack. Okay, so and the good thing about Jetstream is that you can interact with the resource with API, so you can automate all of your deployments. So you can have multiple virtual machines with all the necessary networking deployed on the system. And then on top of that, I have written a tutorial. So you see the link over here to the tutorial where you can also you can deploy Kubernetes on top of these multiple virtual machines. And why do we deploy Kubernetes? Because Kubernetes gives us a very nice interface for orchestrating multiple services running distributively across our virtual machines. And so you have a single point where you can check the logs, you can check the status of all of your services. And Kubernetes is built on top of Docker containers. So you have this, so if you look at this flow chart, this diagram, you see we have multiple virtual machines on Jetstream. So Jetstream virtual machine is a standard Ubuntu with a specific amount of with different sizes, so you can choose if you want a few cores or if you want 16 or 32 cores, and the same thing with memory. And so you have these virtual machines deployed, and these virtual machines have a Docker environment. And once we have created the Kubernetes environment, Kubernetes basically federates all these resources together and gives us a way of launching containers that run specific services. So the first step we do for this deployment is we deploy JupyterHub. Okay, so JupyterHub is a multiple user Jupyter Notebook interface. So what happens is that you have this JupyterHub service running somewhere on your Jetstream cluster. And this is what we're going to do next. So you're going to get from your laptop, you connect to this JupyterHub instance, you authenticate. Today we will be authenticated with GitHub. And once the user is authenticated, the JupyterHub service calls the Kubernetes API to have another container. Okay, that's the container that runs the notebooks and the kernels of a user. And then Kubernetes takes care of all the networking necessary to have this interface to your computational environment back to your browser. Okay, so you will be deriving from your browser the computation which is being executed on one of the machines in our cluster. And of course, if we have multiple users, each user have their own independent section, which is going to be a container running deployed somewhere on this infrastructure. And so the idea is that Kubernetes is taking care of all of the low-level management. So it's automatically assigning the container to run on one of the multiple machines that are within this Kubernetes cluster. Okay. So now that we have a bit of an overview on these systems, let's just log into it so that we can play with these notebooks. Okay, so you should now go to this address. Okay, I'm going to paste it to the chat. Okay. Okay, once you get to this address, you should see a login with, let me just log out. Okay, you should have a sign in with GitHub button. You click on that and you log in with your GitHub account, and then you will see a completion by progress bar that shows you how the your single user session is being launched on JupyterHub, and then you will see the JupyterLab interface. Okay, so can you do a thumbs up on a thumbs up sign on Zoom when you have been able to connect? Okay, and while you work on this, I can show you how I can check on the infrastructure. So you see now I am at a command line, and this is okay. So this is the Kubernetes interface. So basically, I'm displaying all the pods, all the containers which are running. So I see a few people that are running successfully on the machines. Okay. Okay, very good. I see a good number of people that are running. I'm just gonna give another minute. But yeah, if you have any trouble, please write a message in chat to everyone, and someone can help you out in chat. And if there is anything I need to take a look at, please unmute and ask. Okay, so let's continue. Okay, so once you are in your JupyterLab session, you should have something like this. Okay, so first thing we do new terminal, and we open a terminal. Okay, and then we paste this command. Okay, I'm gonna put it in the chat as well. No, sorry, didn't copy the whole, or maybe yes. Oh, no, that was right. Yeah, so it's git clone and that address. Okay, this is going to get all the notebooks that we're going to use for this session under your home folder on Jetstream. Okay, so once you have done that, you should see on the file browser of JupyterLab on the left, you should be the you should see the Dask Jetstream tutorial folder. If you enter inside that folder, and then you can open up 01 underscore environment.ipynb, and you can execute that. Okay, so from the file manager, you should be in your home, you see Dask Jetstream, and then you click on number 1, and you should see this notebook. Okay, is everybody here? If something is not working, please write on chat so that we can take a look at that. Okay. Okay. Oh, sorry. Did the... Okay. Everyone in the meeting. Sorry, went to direct message. Okay. Git clone. There we go. Okay. Okay, yeah, I'll give you a few more seconds to do this. So you should be authenticated to GitLab, open a terminal. So if you don't know how to open a terminal, let me show you again. So from file, you do new terminal. And this is gonna show you a terminal. And then from here, you paste, you should be able to paste with Control V. You paste the command git clone. And once you're there, you open the file browser, and from the file browser, you click on Dask Jetstream and then 01. I have it already open. No. Okay. So if we look, so let me just check the chat again. Okay. Okay. So I'll keep going. Okay, so what now we can execute this notebook cell by cell. Okay, so you see what do we have here? So we have a Ubuntu 22 release, okay, and this is the container that we are running in. Okay, so you see that there is a Jupyter image environment variable, which is telling you what is the container that is being executed. Okay, so if we look at our flow, at the flow chart I saw before, okay, so you are running inside one of those containers. Okay, so there is, for each of the people connected to the tutorial, there is a different container running, and this container has this image which is provided by the Jupyter team that has all the scientific Python packages, so the standard SciPy, Matplotlib, NumPy, and so on. Okay. Moreover, we can take a look at we can take a look at the following cells. Okay, so we see we have a CPU limit. Okay, so that means that we can only use 2 CPUs. Okay, and this is configurable at the infrastructure level. So the administrator chooses how many CPUs each person has, and you can even configure JupyterHub so that there is a menu of options at the beginning, and people can choose different sizes if they need more resources for specific tasks. And this environment, you can also modify this environment by installing new packages. Okay, so if you prepend the design to the to a command. This is going to execute a bash command. In this case, is pip, so you can do a pip install, AstroPy, for example, and this is installing another package. Okay, here we go. And this is the memory limit, which is 2 gigabytes, and all of this is running inside a Conda environment. Okay, here we are using Mamba, which is the same thing as Conda, but it's just more optimized, so it runs faster. So usually recommended to use as a tool to interact with Conda environments. Okay, so the infrastructure still Conda is just another tool that manages those environments. Okay.
Andrea, there's a question from Jamie in chat.
Yes.
He is asking, can you say something quickly or point to a resource that allowed this Jupyter lab to authenticate against GitHub accounts?
Yes. So the deployment of Jupyter is based on Zero to JupyterHub. Okay. So Zero to JupyterHub, I'm going to show the link. Okay. Yes, so Zero to JupyterHub is the recipe that I use to deploy JupyterHub on Kubernetes, and this has excellent documentation on how to configure all the different pieces. Okay, so if you look at the customization, somewhere there should be a way to choose your authenticator service. Okay, and I also have a tutorial about that. So if you go here deploy GitHub authenticator, I'm gonna paste this as well. Okay, very good. And JupyterHub supports all kind of authentications. You can authenticate with GitLab, with Google, and CI logon, and many more. Okay, so now that we have executed this first notebook, is there any other question?
I'm not seeing any other questions in chat other than Jamie thanking you.
Okay. Okay. So if anyone wants to ask can just unmute and ask a question if you have a question now. Okay. Very good. Now, let's go to the next step of our tutorial, which is the tutorial about Dask. Okay, so now, so you are already logged in to Jupyter Lab, so you're just going to go and do check the other notebooks. Okay, so first of all, let's execute notebook 0. Okay, so I'm going to go to notebook 0. Okay, this notebook is just a workaround because in the image that I have chosen, the SciPy notebook image, we are missing this tool, dot, which is really nice because it's the tool that Dask uses to show the computational graph. And so we'll see it next, but we need to just execute this so that this tool is available. So if you just run those cells, and then once you have done this, let's switch to notebook number 2. Okay, number 2, data frame. Okay, so in this first part of the tutorial, I'm going to show you how to use Dask, and for now, we're just going to use it on a single machine. Okay, so we're not doing distributed computing yet. So because I want to first give you a feeling on how the Dask works in a more simple context. And then after these 3 notebooks, we will switch to actually doing distributed computing, where we will rely on Dask to execute code on other workers that are running somewhere else inside our Kubernetes cluster. And then at the last step, we will show how to use object store to read and write data from. Okay. Okay, so let's start with this. So Dask has different interfaces, different sub-modules, um, and the two most commonly used are Dask data frames and Dask arrays. Okay, Dask data frames are basically a parallel version of pandas data frames. So if you are familiar with pandas data frames, the interface is pretty similar, but the power of Dask is that it can help you in specifically in two situations. One where your data frame doesn't fit in memory, and so what Dask can do is can uh, process pieces of your data frame at a time, so that your machine doesn't go out of memory. And the second one is when you want to run distributed. Okay, and for both these tasks, the more important piece is chunking. Okay, so whenever you go and do a parallel computation, you need to decide how um, you want to split the work that you need to do. You have a computation on some data, but you want to split the computation across multiple workers. Or if you even have just one worker, maybe you want to split it still in smaller chunks so they fit in memory, and then you want to aggregate the results. Okay, and so what Dask does is a Dask data frame is actually composed by smaller pandas data frames. Okay, and whenever you do an operation on the whole Dask data frame, under the hood, what Dask is doing is executing uh, the correct operation in all of the different subsets and then aggregating the results. Okay, so now let's execute this notebook, and so we can have a feeling of on the um, interface that Dask data frame has. So first of all, I want to acknowledge Coiled, which is a company that develops Dask. And I took this teaching material from them, and here and I will share with you all of these notebooks. They are in the public repository that you cloned, and there is a link to the sources, and they also have some webinars on YouTube if you want to learn more about Dask. They go in a little bit more detail. Okay, so now let's start by executing a few cells. Okay, this is we just need some data to do some example computations, and so this is a data set which contains a number of different CSV files. Okay, and this is very similar to what you do with pandas data frame. A very common way to start working on data is you have your CSV file, you do pandas.read CSV, right? While with Dask data frame, instead of pointing to one CSV, you can even point to multiple CSV files. Okay, and here so if you're familiar with pandas, you would expect to see some data here, right? You're plotting, you are printing out your data structure, but there's nothing here. And this is where we hit the first peculiar feature of Dask, which is it's lazy. So whenever you call a command, it's not actually executing anything. Okay, so when you do dd.read CSV, this is just reading the first CSV finding out which are all the columns, but it's not actually reading any data. Okay, why is that? So that's one of the most important thing about computing is the graph of dependencies. So you want to know how all of your different tasks are connected. So you want to take a column of your data, you want to do an average or a sum, and so what you want to do when you want to do distributed computing is you describe the whole computation by calling commands, and then at the very end you call compute. So there is so if we go ahead, yeah, you see here. Okay, so let's say that you want to take the maximum of a column. Okay, so this is pretty standard. This is the same thing you would do with pandas. So you have your data frame, you index, you take the name of the column, and so you have your column, and then you call max. Okay. Again, Dask is lazy, so this is not yet executing. Okay, you are describing your computation to Dask so that Dask can understand the structure of your computation. Okay, and so let's go ahead. This GraphViz is just a computational, it's just a graphing tool that we are using. And here we go. So we have our computation, which has max delay. Okay, we call visualize, and this is plotting the this is a DAG, is a direct acyclic graph, okay, that describe your computation. So it's a graph, has arrows pointing, and is acyclic, so it doesn't have any loop, because otherwise with a loop would not be solvable. Okay, so here shows that we have some chunks. So we have 10 different chunks, okay, of our data set, which are the 10 different CSV files. So for each task, what we are showing all the different execution from the bottom to the top. Okay, and so we read the CSV, we do some formatting of the strings that are inside the data set. Okay, and then we do a get item operation. Okay, this is you remember when we call the name here. Okay, this is the get item operation, right? So we are choosing a column, and then we are calling max. Okay, and this is the max operation, but the max operation is done in 2 stages. And so here you see where's the difference between a distributed computing. Okay, so you are doing the maximum for each chunk, okay, and then you are aggregating all of them and taking the max of all the different maxima of the different chunks. Okay, now all of this operation is just done under the hood by Dask. Okay, we just call compute. Okay, so we have the operation that we want to execute, and we call compute. Okay, and now what Dask does is reading all of this in parallel, and then execute all of the steps in our chart of computation to get to the result.
Yeah, I had a question. Is compute right now? This is not doing any multiprocessing, right?
No, it's doing, it's doing multiprocessing just locally.
Okay, so not across the workers. Okay.
Right. Okay, so in our, so we have two cores. So Dask is going to use both cores, okay, using threading. So by default, with data frame and Dask array, it uses threads. Okay.
Andrea, there's also another question from Jamie.
Yeah.
Asking if max delay is only an object prior to execution, that is why you are able to visualize the chunks.
Yes, right. So if we take a look at max delay, okay, you see it's a Dask scalar object type. Okay, so basically what this is doing is describing the computation. So inside the max delay, we have this computational graph. Okay, and so when we call compute, the graph is executed. Okay, but until we haven't called compute, nothing is done. Okay, and so you can chain multiple operations together. So let's continue with a few examples, and then I will stop for questions after this for examples. Okay. Okay, not okay, so here we are taking canceled, we are doing the negation operator, and then we are summing, and then we are computing. So it's a total of non-cancelled flights taken. Okay, then we can do more complicated operations like group by. Okay, so this is the non-cancelled flights by airport. Okay, so you see this is more complicated. So we are taking the data frame, we are indexing it with the column canceled. Okay, canceled is a boolean, so it's doing true if the flight is canceled, false if it is not canceled. We are negating that, so that now true is for the non-canceled flights, and that's what we want. So we are selecting the subset of rows that describe flights that have not been canceled. Then we group by origin. Okay, so now we have split for each origin, we have those rows. Okay, and then basically we count the number of rows and then we trigger computation. Okay, so you see you can chain operations, and it doesn't matter if you create intermediate variables or not. Nothing is executing until you call compute. Okay, and so this is this is reading the data. Every time we call compute, we are reading the data from disk, because Dask doesn't want to occupy memory if it's not specifically required. Okay, so every time we do this, we are reading back the data from disk again. Okay, we will see later there is a way to go around to avoid that, but let's keep it for later. Okay, let's see the last one. Okay, so here we are grouping by day of the week. We are finding the mean of the delay, and then we are looking for the index of the max. So not the max, but the index where the max happens, and then we compute. Okay, and so we see the day of the week 5, which is probably 0 is probably Sunday. So 0 is Sunday, 1 to, yeah, Friday, probably is Friday night. Okay, so let me stop here for questions. So you see how the interface is very high level. So and this would work the same. So the interface is the same. It doesn't matter if you're running just inside your notebook, like we are doing now, or if you are connected to a cluster of 100 workers that are executing this computation. Okay, so that's specifically the power of the Dask data frame and Dask array. They're very high level interfaces. So it feels like using pandas, data frames, or NumPy arrays, but you can leverage much more computing resources. I'm gonna check if there's questions here.
I had a question. I had a question. It's very high level. I'd never heard of Dask before, but I'm assuming, just like in a nutshell, what this library is doing is it's taking native properties such as NumPy and pandas, which are not like they don't really internally do multiprocessing, and Dask is providing an interface for that.
Exactly. Yes.
Okay, sounds good. Thanks.
Okay. So the most important thing, yeah, and it's been yeah, there were a few other parallel libraries, but nothing as powerful as Dask was created before. So once they've published Dask, then there has been finally a big move of the Python ecosystem from just running serially or maybe multi-threads to running distributed. So, and with Dask, you can make that pretty high level. So you it's not as low level as doing MPI. So MPI for, there is also MPI for Pi, right? Which is
Yes.
using the MPI framework to run distributed, but that's a
Yeah. So this doesn't use OpenMPI, like, or does it use a
no.
Does it use
No.
MPI library? Like, how does it do multi-node?
It's purely Python. Okay, and Python, which is calling NumPy under the hood on the different workers. So the actual computational job is done by either NumPy or pandas, which under the hood they are compiled to binaries, right? And so they are fast. They're not. They're fast as C libraries, basically, under the hood. Okay, but the whole orchestration. Parallel message pass, whatever communication needs to be done, all of that is pure Python.
So I had a question. If I was running this on an HPC machine with like multiple nodes, will this work on multiple nodes?
Yes. So Dask also works on HPC. Yes. So you can run. Yeah. There's great documentation. So you can find on the Dask website. You just Google for Dask. Then they have examples on how to run on HPC.
Okay, so just
also there's a link in chat for more information on Dask.
Oh, I see that. Yeah, thank you. All right. So, all right. Yeah, thank you for those. Thank you for the answer. That's been good.
Yeah.
And
so
Andrea, there's two more questions as well. Jamie's asking, to be clear, Dask only operates using OpenMP, or will it do MPI or hybrid? And then Jack.
Okay, so no. Dask doesn't use neither MPI nor OpenMP. Okay, so multi is using the Python equivalence basically. So it's using, if you're running locally, it's using multiple threads, and if you're running so basically if you're running locally, you have the option. So you can use the threading backend or the multiprocessing backend. Okay, and so the advantage is the threading backends has lower overhead because you're just using threads and you can share memory between the threads, but you could fall into problems with the global interpreter lock. So this is a Python feature which doesn't allow objects to be, when you have Python objects, they don't allow those to be modified by two different threads. So if you have two different threads that are accessing Python objects, they have to wait. One grabs the lock and the other one has to wait. So you don't get anything by running with multiple threads, okay? Currently, a lot of more and more projects are releasing the global interpreter lock while they execute. For example, both NumPy and pandas do that now. Okay, so in that case, you can also leverage multi-threads without worrying about the global interpreter lock. Okay, and so locally you can run with threads, we can run with processes, and then if you have a remote, if you run with remote workers, again, each worker has one process and has a number of threads equal to the number of cores that are in your available to that process. Okay. So let me see if there's any other question.
So actually, I had one other quick question, if you don't mind.
Yeah.
Since we're on the topic of Dask here, I was curious about the support for the library polars, similar to pandas. And it looks like, well, I want to get your thoughts. It looks like Dask does support polars in polars data frames. I guess what's been your experience, or do you have any experience with that?
No, actually, no, I never used that library, sorry.
Okay. Yeah, it's similar to pandas, but it's built on Rust. And looking through here briefly at some quick articles, it looks like Dask does support it. And I see there's a lot of various articles comparing Dask and polars and the benefits. But anyway, thanks.
Okay. 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 Yeah, so about the dog, yeah, exactly. No, you cannot import something. It's just you'd use the pandas, use the Dask API to create the to describe the different operations that you want to do to your data set, and under the hood, Dask is writing the DAG to keep track of your computation. Okay, now let's take a look at one functionality which is a little more lower level, okay, which is map partitions. And so what happens is that in Dask parlance, a partition is each one of those chunks, okay? So when you have a pandas, a Dask data frame, each pandas data frame, which is each chunk of your Dask data frame, is a partition. And so you can also tell Dask to execute a specific function that you write to all of those partitions. So for example, here is a simple example thing where you're just subtracting 2 to your data set. And so you can, you see, select your column, and then you do map partitions. And this is going to be, so still, if you think about it, it seems like a simple functionality, but to implement this, you have to take this function, ship it to the workers, execute the function on the workers, and then get the results back. So still pretty powerful. Okay, and then we can. So you see, when some of the pandas, some of the Dask functions, they trigger compute. So you see here, there was no compute anywhere, but head is triggering compute. But is triggering compute just on the 4-5 elements. So it's executing just enough of your pipeline to get the results for your first 5 elements, okay? So in this case, we have a bunch of CSV. It only loaded the first CSV because so thanks to having access to the computational graph, to the DAG, knows exactly what are the requirements for each region of your data. So if you are if you just need the first 5 rows, then it's gonna just read the first CSV and do all the computations. Okay. Okay, let's go ahead. Okay, another powerful thing is you can, instead of calling compute on each of this, you can call compute at the same time on multiple objects. Okay, and this is very powerful because Dask is going to check how some common parts of your computation that are used by both pipelines and just execute them once. Okay, so you see that if we execute them separately, it's taking 7 seconds. If we execute it at the same time, it's just gonna take 3.5 seconds. Okay, because Here, it's loading the CSV, doing the computation of the mean, and then starting again. When you do the standard deviation, you recompute you have to load the CSV again, while in this case, Dask knows that you want to compute both. So it's reading one CSV, computing both the mean and the standard deviation in one pass only. And so it's a lot faster. Okay. And so the trick with gaining more performance out of Dask is that you want to do as much computing as you can in one single call. Okay. Because under the hood, Dask can do a lot of optimizations for you. Okay. For example, we can even visualize both of those computations. Yeah, this is, you can take a look at this later, maybe. It's really a huge computational graph, but has a lot of, you see those horizontal lines over here, means it's reusing the same computation on different parts of the pipeline. Okay. Yeah. Oh yeah, there's also a way of downloading this and then visualizing it better, but okay. You can take a look at that later. Okay, and this is it for Dask data frames. Now let's take a look at Dask arrays. Okay, so this is similar. So we have a big Dask array, which doesn't need to fit in memory at this point. And then you decide to divide it in chunks. Okay, so here is a 2D array, but of course this works with any dimension of array. And so you have each chunk. This is divided in chunks that are NumPy arrays. And then when you do a computation, Dask is going to execute the computation on all the different chunks and then aggregate whatever needs to be aggregated to get at our final result. Okay, so yeah, let's just execute the first cells that are just for creating data. Okay, so what's our data set like? So this is some random numbers, some random floating point numbers that are stored on disk in the binary format HDF5. Okay, it's just a binary format. And what we want to do is let's take a look on how you would compute the sum by doing a chunked algorithm yourself. Okay, so you can even do some chunking manually. So you see what this is doing is loading a piece, a million elements, okay, from index I to index I plus 1 million. So it loads in memory 1 million numbers, does the sum for each chunk, and then at the end, what you have is a list of all the sums of all different chunks, and then you do the sum of the sums so that you have your total. Okay, well, Dask array basically is doing the same thing under the hood. Okay, but the nice thing is that yeah, so you don't have to to do all these low-level computations. Okay, this is very error prone. It's very difficult to now, and this is just compute the sum of an array. So if you think about a real computation with multiple steps, this is very complicated to handle. While with Dask, so you first turn your data set, okay, which is a file object, which is the HDF5 file object, which has a similar interface to an array. Okay, so you can do just Dask array from array. And then this is the important thing. This is the parameter that you have to choose. Okay, it's the chunk size. And on the Dask website, there are several suggestions on how to choose chunk size. So you don't want to have chunks too small, because if they are too small, you are wasting a lot of time orchestrating all those tiny jobs, and your computation is not going to be efficient. Okay. On the other hand, if you have chunks too big, if they don't fit in memory, then a single chunk needs to fit in memory otherwise. But not only, you don't want one chunk to fit in memory, you want at least as many chunks as your number of cores that you are using. So if you are if you are on a machine with 16 cores, okay, you want to have at least be able to load 16 chunks into memory, or maybe and then you want to have some margin. And so with that, you can just try to guess one chunk size, and then you can just run some benchmarks and see what size of the chunks runs the fastest. Okay, and so you see this, we want to compute the sum. Same thing, Dask is lazy, so when you call sum, nothing is executed. Here we go. Finally, we are executing when we call compute. Okay. And then we can do the standard deviation. And then, yeah, down here is just showing you another way. This is basically showing you how you have a lot of small Dask arrays. So you see we have many, many files here. So for each file, we have a data set. So now we have a bunch of files. And then we use stack to turn them into a single Dask array, three-dimensional. So we have time on one axis, and then we have longitude and latitude on the other axis. Okay, and then we can plot. We can take the mean over time, and then you see the shape of the continents. So this is a meteorological data set. Okay. And this last one is also pretty interesting. Shows you how if you have NumPy, your array is created, the whole array in memory. Okay. And so you need to have space for that array, and you cannot use multiple threads generally. Okay, and then with Dask instead, you can have this is made in chunks, so you create random numbers just in 1000 by 1000 arrays, and then you can do the computation on those. Okay, now yeah, we need to go ahead a little faster to stay on time. Okay, so your best bet when you have computations is to use Dask array and Dask data frames. However, sometimes your computation is a little more complicated, okay? And then you might want to use a lower level interface, which is Dask delayed, okay? So how does this work? Okay, so let's say that you have some functions. So you see these two functions, they take 1 second to execute because they have a sleep of 1 second. Okay, so you have your 3 functions. It's going to take 3 seconds to execute. Okay, now if you call delayed just on the function, okay, so you see I'm not calling delayed on okay, so you see I'm calling delayed just on inc, and so this is giving me back a new version of the function, which now can run asynchronously, okay? Can be managed by Dask to run overlapping with other functions, okay? So you see we have our computational graph as usual. And so you see every time you have different, basically different columns on this computation, that means that portion of your code can run parallel, okay? And this makes sense because the two increments are independent. So we are incrementing 1 by 1, we're incrementing 2 by 1. It's okay, they can run in parallel, they don't have dependencies. And then when you call add, you want to have the result of x and y combined together, okay? And so when you call compute, this is now going to take just 2 seconds, okay, with a little overhead, okay? And so because the function can run simultaneously. Okay, on our course. So same thing, we can scale it up a little bit by doing now 8 different computations. Okay, so you see here we are executing the incrementation function 8 times for each element of the array, and then we're summing the results. Okay, and so you see here we are calling delayed both on the inc function and on the sum function. Okay, and so you see now what we get. We have something that potentially can execute with 8 threads in parallel. Okay, but unfortunately on our session we only have 2. Okay, so we are just executing 2 of them in parallel at the same time. So Dask is going to be executing the first 2, save the result, execute the second 2, save the result, and so on until we are at completed execution. Okay, so the other way is to use delayed as a decorator instead of a function, but that works the same. Okay, so you could use this, for example, you could use delayed to have, if you want to overlap, for example, computation and data access. So let's say that you are reading data from disk or you are reading data from network. Okay, so you need to wait for data transfer, and then you want to do some computation on this. So what you could do is you can do computing on the first part of your data while you are loading the second part of your data, so that once the second part of your data is loaded, then while you compute on the second, load the third, and so on. Okay, so you could make your code parallel this way without so this you can implement your own functions without using the Dask array interface, or you could even combine those together. Okay, so this is just showing a little more complicated examples, but nothing. Okay, so I'm going to leave this cluster running for the whole day. So if you want to dig a little deeper on this, you can log in later today and you will have it available. Unfortunately, I have to then delete the cluster for tomorrow. So only today this will work, but I will also share all of these notebooks so you can also run them yourself.
Excellent
Okay.
job. I do have a question for you though.
Yeah.
One thing you didn't say was that initial bit of actually getting a Jetstream2 allocation. So how could we do that ourselves?
Yes. So maybe Julian or Lemay, can you paste information about that?
Yeah, certainly. We can put some information in the chat about that.
Yes.
But yeah, it should all be in our documentation. But it's through, the short story is you get an allocation through the Access CI allocations and then spend credits. But I can link it in the chat.
Okay, thank you. Okay, so let's switch to using multiple cores. Okay, so now what we want to do is, okay, we can execute this in parallel, but we're still just using a couple of cores. What we want to do is we want to spawn workers somewhere else on our Kubernetes cluster and connect to those and dispatch some job to be executed. Okay, so and this is where Dask Gateway comes in. Okay, here you can, I have the tutorial on how to deploy Dask Gateway on OpenStack. And so what Dask Gateway is another service. Okay, it's another service, runs on a container on our Kubernetes infrastructure. Okay, so I've deployed this service. So this is something that the administrator of the deployment does. As from the user's perspective, what you're going to do is you're going to, from your notebook, you connect to this service and you ask for workers. Okay, and now Dask Gateway is going to call the Kubernetes API to have other containers, so it's yet more containers, a lot of containers, that are being launched wherever there are resources available on our machine, on our cluster of machines. Okay, and a Dask cluster is composed of two different things. One is the Dask scheduler. The Dask scheduler is a service which is basically interacting with your notebook and is going to coordinate all of your jobs. Okay, so from the notebook you connect to the scheduler, and then the scheduler itself is going to tell the workers what to do. Okay, so whenever we run in this configuration, you are actually not loading data on your notebook, so you're not using any memory on your notebook instance. Okay, it's the workers that are executing. Okay, so if you do load CSV, is the worker which is going to connect to disk and load the CSV. Okay, you're not going to have anything in memory over here, so you are doing interactive computing by driving your computation from the notebook, but the computation is executed elsewhere. Okay, and okay, so you can Dask gateway also works on attached to an HPC resource, so you can have Slurm. You can have Slurm launch those scheduling workers. You can look in the documentation of Dask gateway, which is pretty extensive. Okay, very good. So let's take a look at this in action. So go back to your JupyterLab instance and let's execute 05. Notebook 05 Dask gateway. Here we go. Okay, so so the first step here should not be necessary if the administrator of your cluster builds a Jupyter Notebook image which has already Dask gateways. I didn't want to do that, and so I'm just keep installing stuff. But with more time, the administrator should be able to have this already available, so you don't have to install it every time. Then here is where you connect to the Dask gateway. So you have access to that service. So you can tell it to list the clusters that are running. And if there are any, you can ask to stop those clusters. Okay. And then here you can choose the number of cores and the memory. Okay. We have a lot of resources available, so if you want to increase this a little bit, you can get 5-6 workers, no problem. I think we have a maximum of 8, if I'm not mistaken. Okay, so this is the number of cores per worker. Okay, and this is the number of memory per worker. Okay, or you can use just this interface to select it from there. So and then here is where you create the cluster, and then you tell it to scale to 2 workers. Okay, so now I have 2 workers, and each worker has, in my case, 1 core and 2 gigabytes of memory. I think in your case should be 2 cores with 4 gigabytes of memory. Okay, and don't worry about this warning; it's normal. Okay, so now whenever you create a client object, okay, whatever Dask calculation, whatever Dask call you are doing after having created a client is going to go through the client. Okay, so the code doesn't change. The code is the same if you're running locally or if you're running remotely. Okay, which is pretty powerful. The only thing is you have to create this client first. Okay, so now that we have the client, the Dask commands that I am executing are running on the workers. Okay, and now the best feature of Dask is the dashboard. Okay, so inside the client, you should have the link to your own dashboard. Okay, so each of us has a different cluster of workers. Okay, so if you click, so let me do this. Okay, and let's put it side by side. Okay. Okay, what is the Dask dashboard? So the Dask dashboard is showing us in real time what is happening across what computation are executed in our cluster of machines. So this is really powerful because one of the most complicated thing about distributed computing is understanding what's happening, right? Because it's really hard to debug a distributed system. So this makes it a bit easier. Okay, so if you click, and then there's more information about everything. So if you click on workers, okay, you should see your 2 workers, or if you have more workers, whatever number of workers you have, it's showing you CPU usage, memory usage across your machines. So it's really nice. Okay, so now let's execute some code. Okay, so here I'm going to show you another function of Dask, which is used a bit less. Okay, so this is similar to Dask array, but it's designed for running simple independent function. So if you have just one, if you want to apply the same function to multiple data sets, and you don't need intercommunication like Dask array is doing, then you can just use Daskbag, and you see the main interface. Usually you use map. Okay, this works the same as map in the Python standard library, where you pass it a function, and this function is applied to all elements of your data set. Okay, so you see I executed, nothing is happening because Dask is lazy. And when we do compute, here it is. So you see in real time, it's telling me that the slow half, you see, those are the 2 threads that I have. Okay, and the thread is executing slow half here and slow half there. Okay, now let's do a more complicated. So now we have we are creating on the fly a random array with some chunk size, and we are computing the mean. Okay, so we execute this. Here it is. So you see in real time on the right, we can see the time spent on all the different operations. So you can even click and look at it more in detail. Okay, and the most important thing that you get from here is looking at the red parts. Okay, so the red here shows you the time that your workers are spending for communication. Okay, so generally, if you have a lot of red streaks, that means that your workers are waiting for data transfer. Okay, and that's bad. It means that you're not using the CPU that you have, right? Workers just idle, and so that's a great way of understanding if your algorithm is running properly or not. Okay, looking at this is not running properly. There's too many red parts. Okay, why is that? Probably we have chunks that are too small, and so we should try to increase, because we want to give more job to more tasks to execute. No, we want to give larger tasks. Okay, so a CPU to run efficiently wants to have a big array, so it can quickly run through. Okay, we are probably here, we are getting too small chunks, and so we're wasting a bit of time on data transfer. Okay, and this is how you debug your distributed computation. You look at the graph and you understand where your code is spending more of their time. Okay, so yeah, this is a very simple computation. So we are just basically doing a normal and mean, so there's not much to see. But on more complicated computation, this gets very interesting. Okay, another simple thing that you can do is you can just execute functions remotely. So you have your run on worker function, which just prints the version of Dask that you have. Okay, if you do client or running, you give it a function. This function is shipped to the workers, executed on the workers, and then comes back. Okay. So let me see. Let me see if I see the workers, some workers running here. Okay, so you see that I see a bunch of schedulers and a bunch of workers running on the cluster. Okay, so that means that that some of you have those workers running. Okay. Okay, remember to execute also the last cell, which shuts down the cluster, so that you don't have just workers idle waiting for some computation to do. Okay, then I'm going to close the dashboard. Okay, so now let's execute 06, and then I will stop for questions. Okay, so 06. So same thing. This is just the same example with a different computation. Okay, so you see now the short version. I'm just getting the cluster, scaling to 2. I'm using everything default. And I have my client. Once I have the client, I click on the dashboard. Same thing we did before. Put one here, one there. Okay. Now, okay. So now we are executing 7 gigabytes of data. Okay. And okay, so let's see. Okay, here we go. So this is the computation that we're executing. Okay, so you see it's showing you in real time how all the different workers are working. Okay, we could do a result dot visualize format equal SVG. Okay, so I'm using SVG because the standard is not supported, but if you are running on a different environment, then you can just leave out the format thing. Oh no, maybe this one is too complicated and it doesn't execute. Oh no, yeah, executed. Okay, yeah, so you can see here all the different steps of your computation. Okay, very good. So now I wanted to show you persist. Okay, so I told you before, so every time that you execute the computation, Dask is cleaning out all the results. So you see there's nothing stored in the workers. Okay, because we don't want to use computational resources on the cluster unless we specifically request that. Okay, so you see now, if I call data.persist, okay, this is going to take our computation and so let me see. Okay, you see, he's computing, but now he's saving that into memory. Okay, and you see we do not have enough memory to store 7 gigabytes of data, even across our cluster. So this is actually spilling to disk. Okay, and this is of course data which is spilling to disk is going to slow down a bit, but still if you have, for example, you have this big data cleaning process, and then after the data cleaning you want to perform different type of operation, a good way is you call persist, so that now this array is in memory, and if I call compute again, okay, before it took 10 seconds, now it should take less than 10 seconds. We'll see, but let's see. No, it takes about the same. So probably it's probably because this operation is pretty efficient, because it's just creating data in memory. So it's actually very fast to create the data in memory that pre-running them and saving them to memory doesn't help. Okay, but if you have a complicated data processing pipeline where you are loading big data from disk, you're cleaning them, you are reducing the size, then it's worth using this technique. Okay. Okay. Is there any question about using Dask Gateway? So let me show you again the architecture. Okay, so this is what's happening. We are working on the notebook and we are executing on the workers. Okay, and so this allows you to use a lot more memory. So you can configure workers to have tens of gigabytes of memory each. Okay, and a lot of threads, and so what you can do is you can execute the similar calculation to what we did before on the. You can use Dask data frame and Dask array on this infrastructure. Okay,
Hey,
is there
Andrea,
any question?
I'll ask a question with respect to the gateway. So you have it implemented on Jetstream. How could we implement it, or perhaps even further down, should we implement it on our standard university clusters that are just running Slurm, on just the standard non-containerized kind of environment?
Yeah, if you look on the documentation of Dask Gateway, shows you how, you see here, install on HPC job queue. Okay, so you can take a look. You can take a look at this, everyone. Okay.
Okay, sounds good. So I've been using Dask before, just with the standard job queue. I believe if I remember it right, it just started the Slurm job, and the workers were in the Slurm job. So how different is the gateway from there? Or am I asking the right question?
No. I see. Yeah, I used job queue in the past. Yeah, the difference is that this is centrally managed from. The main difference is that it's the HPC admin that deploy this service, while with DOS job queue, just do it yourself. Okay, and so it's easier for the user because they don't have to worry about too many details. Okay.
Yeah, makes sense. Yeah,
so you see how easy it is. You have this, and then you even have with that job queue, you have to write a template Slurm, or it's a lot more complicated. Well, this you just call the gateway here, and then you even have a GUI. You can choose your image, and then it's just running. So it's a simpler interface. Is there any other question?
Yeah, I had a question, and this might have been asked. I just had to step out for a bit, and I came back, so I'm sorry if it's the repeat question. So when we're using this in an HPC environment, for example, and we want to have like a user come in and start to use Dask in the Python code, does the gateway have to be running at all times in the background so that they can use it, or can the gateway be turned off when no one is using Dask, for example?
No, I mean the Dask gateway itself is just a simple service, so it doesn't occupy many resources. So you could have a machine which is running Dask gateway, and then you tell the user the address of that machine so they can put it here, and but it doesn't. So the Dask gateway is not doing any computation. Dask gateway is just handling launching the workers, launching the scheduler, telling the client how to connect to the scheduler, and so you don't need much resources. You can have a tiny virtual machine handling the gateway, and then tell the user the address of the machine, and the user can just connect to the machine and request Dask clusters.
Okay, and can multiple users use the same gateway?
Oh yes, absolutely. Yeah, that's the main point of the gateway, is to be a central point where the user requests resources, and then each user has their own cluster. So the clusters are all separated. They are private to each user, but the gateway is a shared resource. Okay. So you see here, there is a central gateway, and then gateway is spawning this resource. So this is the worker of user one. So it's just for user one. And then once user one is finished, they can delete the workers, or as an admin, you can also set a timeout. So after a few hours, people are not using it, then the cluster gets automatically deleted by Dask gateway.
Okay, thank you.
Yep.
Perhaps
Okay.
I would say just to follow up quick on his question. He actually was asking about the same question I was about to ask. But to be clear, if we are using Slurm or PBS schedulers, we would need to deploy, well, the service that. Oh, I guess. Do I understand correct that there would be a daemon running on the compute nodes that we have configured?
No.
Or there wouldn't.
No. No, the daemon is running independently.
Okay,
so
so
there
we
is
wouldn't need to deploy that out to the.
service which is running on a virtual machine somewhere. Okay. So you're gonna have this Dask gateway which is running, or you can even run it on a login node, one of the login nodes, but then from the other login nodes, people would have to connect over the network to this login node to ask for a Dask cluster. Then the Dask gateway is gonna launch a Slurm job for those users, and once the Slurm jobs runs, then they can connect and execute their jobs.
Okay, I think I'm following you now. All right, thank you for that clarification.
Yeah, I had a follow-up question. Is it possible that we do it the other way around? For example, a user comes in, requests...
Yeah, this is going too much in detail on this.
Okay,
if you want to send me an email, there is my email address over there.
Yeah, for sure.
Also, yeah, it's focused on HPC and not much on Jetstream. Okay, so let's continue, and we're gonna do the last notebook. Okay, so the last notebook is going to be about data storage. And so another service which is provided by Jetstream is Object Store. Okay, so Object Store is a scalable data storage option. So which is like Amazon S3. Okay, so you can store your files over there, and it's nice because it's managed by the Jetstream team, so you don't have to worry about managing anything else. You can just create a bucket, like a folder basically, and inside there store your data. And in particular, this is more efficient if we use Zarr. So Zarr is a binary data format, so it's similar to HDF5, but is specifically designed to run on cloud resources. Okay, and how does it do that? By storing your data in chunks. So you remember that chunking was one of the most important concepts in Dask, because it allows you to split your work into multiple pieces. Okay, and so of course, we also want our data to be split in pieces at the source, so inside your object store. And so Zarr, you create one file, but under the hood, that single file is stored in separate chunks. And this allows our workers to have parallel access. Okay, so this works a bit like parallel files. It's a way of doing like parallel file systems that we use on HPC on the cloud. Okay, so you store those chunks, and then parallel workers can access concurrently to multiple pieces from different parts of your infrastructure. Okay, so let's open up the last notebook. Sorry, I made a mess. Okay, here we go. This is number 7. Zarr Object Store. So as usual, I have a tutorial on how to use this on Jetstream. The link is on the slides, and I will be sharing the slides after the talk. Okay, so as usual, I install the requirements. We shouldn't be needed generally. Okay, and so you see here, to access our data storage, you have a key and a secret, and there is the link here on how to create your own. But for now, you are gonna write on my bucket. And so you see, we connect to this S3 file system, okay? And we see there is a, inside this bucket, there are different files, okay? And these files, so they're named Zarr test dash and the name of your user. so that each of us is going to write on independent destinations. And so you see, you create an array in Dask. So this is a Dask array. Okay, Dask is lazy, so nothing has been created yet, of course. But you create a random array, and then you tell Dask to store the array inside the container Z, and Z is a Zarr file which is living under that name in our object store. Okay, you see it has its own chunks and its own shape, and calling store is triggering compute, is triggering computation. This is one of the operations that triggers computation. And so now currently we are, so you see, I'm not calling Dask gateway, so I'm just working on the notebook just to make things simple. But of course, the main point of this is to do it across multiple workers. Okay. And then you can see how this is stored. So you see it has a .zarray files, which includes metadata, and then has each chunk is a separate object. So 0, 0, 0, 1, 0, 2 are the different parts of this array, different chunks. And so this is all automatically handled by Dask. So if you point Dask to this data set, is automatically going to be able to run this in parallel, create a Dask array, and then on the Dask array, you can do all the usual computation using the standard API. Okay. Very good. We are on top of so time is over, but yeah, I just finished. Okay, so if you want to note down this URL, okay, I'm gonna paste it on the Zoom, but yeah, we're gonna also email it to everyone. So this has the links to the slides, to the repository. Okay, so email me if you want to know more, and I'll also be at Gateways in Pittsburgh if you want to meet there. And also I have funding from Indiana University to work on this topic, so Kubernetes deployments on Jetstream and all the related services. So I can help you out. I can provide support. So contact me if you are interested in deploying any of this, or if you just want to inquire if using this architecture would be suitable for your gateway, please get in touch with me. Okay, and so now let's see if there's any more questions on anything we covered today, but the tutorial is finished, so if anyone has to leave, please feel free to do so.
Yeah, say a quick question. Well, first of all, this was great today. Thank you very much. Do you have any plans to be at SC conference in a few weeks?
No, unfortunately, I'm not going to be there.
Okay. Are you aware of anyone else covering Dask? There, I haven't seen it on the schedule, but I may have missed it.
Yeah, unfortunately, I don't know.
Okay.
I don't know. Sorry.
That's all right. Thanks.
Yeah, I think.
Is there any other question? Okay, very good. Thank you, everyone. So get in touch with me if you are interested in any of this. And thank you.